Dear students, I welcome you all in my class of CIS 3158 Mobile Applications and Game Development. We are in week number 8 and the focus of this week is on alpha beta pruning. This is part number 2 of alpha beta pruning. In the first part, we discussed the aim and objective of week 8 session. The aim and objectives are listed here. Two aims we discussed in the previous part, that is in part number 1, and 4 objectives. In part number 2, I will be covering objective 1, that is this, in part number 2 video lecture. So in the next slide, what I have done, I have provided some bullet points to explain what is alpha beta pruning, and then I will take one example to present the importance of alpha beta pruning for Minimax searching tree. So here you can see, as I said, I have given some bullet points. So alpha beta pruning is an optimization technique. So what we want to do, we want to improve the performance of Minimax searching algorithm. That is the reason we want to apply the concept of alpha beta pruning for Minimax searching. Here in alpha beta pruning, the word pruning defines cutting down the branches. So what does it mean? If you remember, when I explained Minimax search algorithm, I took one example, and the example was on tic-tac-toe game. Suppose this is a game, and in this game the scenario is like 0 is here, 0 player has placed the symbols here, then X player has placed here, then O player has placed O here, and then cross player has placed cross in this block, then again O player has placed O here, and then now it's turn for the cross player to take the move. So what are the different states here? So first, cross player can make a cross in this block, that is here, or he can make cross in this block, or in this block, or in this block. So what we will do in case of Minimax search, we will consider all the possibilities as one state. So here we have, this is one possibility, this is second possibility, third possibility, and fourth possibility. So we will get 4 different branches, 4 different states from this state. So this is one of the state. I am calling this as state 0. So from this state we will get different state like S1, S2, S3 and S4. But all these states are not have equal importance. We are going to select any one of them and we will cut rest all while making the decision. So alpha beta pruning helps in cutting the branches which are not required. So pruning means pruning the useless branches, that is cutting down the useless branches of a decision tree. So this structure represents a tree, and this is known as decision tree of Minimax algorithm, search algorithm. So we call it Minimax search tree. The next important point for alpha beta pruning is for the implementation purpose. So suppose you are going to implement the features of alpha beta pruning for Minimax search. So what you have to do, you are going to add 2 extra parameters in the Minimax function. So suppose you have created a function and the name of the function is Minimax, and here you have given parameter 1, parameter 2, or it's better to take the same parameters which you have used in week number 7. So you have created a function, and the name of the function is min max, and it has 3 parameters: state, list or limits, and players. So in the last week you created this function for minimax search, if you remember, in week number 7. So what you are going to do, this function you created to implement the features of minimax searching algorithm, or to create minimax searching tree. But if you are going to add the features of alpha beta pruning, what you have to do, you are going to add 2 extra parameter to this function. That is, so the new function will look like this: function minimax and state. This parameter will be as it is, then limits, then players, and then you are going to add 2 parameters. The first parameter will be alpha and the second parameter will be beta. So while coding, you are adding 2 extra parameters to extend your programming code for alpha beta pruning. The same I have explained in the next slide. So this is the function you created in the last week, function minimax. This is the name of the function, and it has 3 parameters: state, limit, and player. So player, as far as the player is concerned, you created 2 players. Player 1 was the human and player 2 was the computer. Now in week number 7 for minimax search. Now in week number 8, what you are doing, you are adding the features of alpha beta pruning. And as I said in the previous slide, if you are going to implement the features for alpha beta pruning, you are going to add 2 extra parameters, that is this and this, that is alpha and beta. And here, since we are adding these 2 parameters, therefore I have updated the name. I have just changed the name. So rather than using minimax, I have used alpha beta. So this is the only difference in the function structure. So here you are going to use 5 parameters. These 3 you already used, and you have added 2 more parameters for alpha beta pruning. Now in the next slide, I have given one example to present the importance of alpha beta pruning for decision making. So suppose we have a game tree, and the structure of the game tree is like this. This is the root node, this is one vertex, second vertex, and third node, and here I have 3 at terminal node, 5 at terminal node, and 10 at terminal node. This is 10. Now this one is 2, and there is no value given here, and there is no value given here, and because and here you have 2 at terminal node, 7 and 3. This is where you want to find out the maximum value, because you are applying minimax search, and here you will find out the minimum value. So how this tree will work and how you will make the decision using this search tree, we want to apply minimax search decision. So minimax decision is equal to, we want to find out maximum value at the end. So this is what we want to determine. We want to calculate maximum value. So we want to, in order to find out the maximum value, what we will do, we will evaluate the minimum value at this node, minimum value at this node, and minimum value at this node. So for the first node, the minimum value will be from 3, 5 and 10. So I will take 3, 5 and 10. Similarly, for finding the minimum value at this node, what I will do, I will apply the function min. So I am writing it here, min. I have one value 2, but I don't have value at this node and value at this node. So I am assuming the value is A and the value is B. Then for this node, again I will write min, and the values are 2, 7 and 3. So it is 2, 7 and 3. And then this. So here max this, from this we will get minimum is 3. From this, since these two values are unknown, so I am selecting C as minimum, and from this we will get 2 as a minimum. Now at this stage, the role of alpha beta pruning comes into picture. So here we cannot find out the maximum value because we have one unknown value. So what we will do, how we will find out the value of C? So here in this case, what we will do, we selected C from 2A and B. Because we selected C from this, because we did not we did not select 2, it means that 2 is not the minimum value. So it means that C, if 2 is not the minimum value, it means that C is the less than 2 or it is equal to 2. Because we have not selected 2, it means that these two values A or B may be either less than 2 or equal to 2. So if this is the case, then we can say that maximum of 3, C and 2 will be 3 because C is less than or equal to 2. So we will get 3 as a maximum. So what does it mean? It means that so here the question arises, and the question here is, do we really need to calculate C? The answer for this question is, of course not. Because without determining the value of C, we can find out 3. So it means that, what does it mean? It means that we could have reached to a final result, that is 3, without looking at these nodes. So what we are doing, we are cutting these nodes, and if we are not calculating what is the value at these nodes, it means that we are improving the performance. We are saving our time. This is what alpha beta pruning does. So this is the situation where you will see that alpha beta pruning comes into the picture. In the next part, I will discuss the working of alpha beta pruning with the help of one example. Thank you very much.